Hi, I'm Ryan, and you're watching a YouTube series on functional programming. In this episode, we're going to talk about the either container. And the either container is really interesting because it lets you encapsulate code branching. And what that means is you can capture an if condition and an error condition in the either container. That's really interesting and it's really cool the way it does it. So let's get started. It's going to take me more than one video to explain what the either does. So I'm just going to copy a bunch of code from one of my previous classes, the previous container, and I'm going to be deleting some of the code from there just to make things easier for us. So I went here and I'm going to call it the either container. The way the either container handles code branching is by returning a right when the condition is true or success, and a left when the condition is a false or a failure. So let's go ahead and define that. So we have a class called right, which extends either, and we also have a class called left, which extends either. These two classes mainly differ in terms of the map function. So the map function in right accepts a function and returns new right of f of this data. So it executes the function and return and wraps it inside the right. And the map function in left does not do anything at all. It simply ignores the function that you passed in and returns itself. That is all it actually does. It does not operate on the function that you passed in. It simply ignores everything. And this makes a huge difference. So let's actually also define the off function here. So the off function in 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 right is static off, is simple, it returns new right of data. And interestingly, the off of either also returns new right of data. And that's because an off, an either, and a right both represent data that can be used to chain further, whereas a left, even if you can chain it further, does not do anything with the data. So you do not have a left off. You never use a left off. You always use a right off or an either off. So technically, if a function returns either a left or a right, it is returning an either because both of them are subclasses of an either. So to see how we can use this, first let's see a regular example of a case scenario I just wrote up. So for the sake of time, I wrote a bunch of functions here. So let's look at this. So we have a function here. Let's say you're trying to access a game. You pass in the user object, a game object, and you say, hey, is the user age greater than the min age of the game? If yes, I'm going to return a game. And if no, I'm going to say, I want to say that you need to be above the min age to access this game. So a simple function, right? With a simple if condition. So I have a user object here. I have a game object here with the min age, with the path, and with the publisher message. Simple stuff. And then I have a bunch of functions that will eventually run depending on whether the user can access the game or not. So the first is a print error, the second is a publisher message, third is a load function, and in this case I'm not loading anything, I'm just printing the path of the game. In the traditional way of writing code, what you would do is you would say, okay, I want to run this function, pass in the user, pass in the game, and if if the result is a string, I'm going to print out the error. And if the result is actually a game, I'm going to show the publisher message, and then I'm going to load the game. So it should be result, there should be result here. So I'm going to use the result, I'm going to show the value, depending on success or failure. So this is how you would do it in the traditional sense. So how would you do it in the functional programming world? How would you use an either in this case? The way you would do it is by redefining the access game function. So I'm going to comment this out here, and I'm going to comment this out here, and I'm going to redefine our access game function. So what I'm going to do here is very simple. Instead of returning a game, I'm going to return a write of game, because this is my success condition. And instead of just a value here, I'm going to return a new left of the message. And notice I did not use left of, because of is inherited from either, and that returns a right, and doesn't make any sense for a left to return a right. So we simply return left of, so that all it does is contain the value but does not do anything with it. So the way I would do it is the way I would use this is I would say access game with user and game, and then if I want to map over it, I can say map, and then I can say I want to load, right? I want to load the game. So I do this. So let's go and run this. So nothing happened. Why did nothing happen? See, because you have the age of the user is 12 and the min age of the game is 18, so the user cannot load we cannot load this game for the user, right? So let me make it 22. So what happens now? I'm able to load the game. That's pretty cool, right? I could also say show publisher message dot map load, and I have the publisher message. I am able to load the game. After that, I show all of that stuff. So I was able to map on it twice. I could keep on mapping. I could continue the chain. But if I change the age again, go back, and nothing happened. And notice how there is no code branching, there is no if-else condition over here. So this whole chain of events keeps on running, assuming that the data is correct. And if at any point of time the chain cannot run because it's a left, all the functions that are passed to map are simply ignored, because that is what a left does, right? A left will ignore whatever you want to map over it, whereas a right will execute the map function. So that's exactly why our code did not break. We did not get any kind of errors when we simply ran this code. The other interesting thing that happens when you have a left or a right is, uh, notice how I had to run this function twice to see the left or the right value. Uh, what you eventually want to do is you want to say that, okay, run the whole chain of functions, and eventually, if the value is right, do something. If the value is a left, do something else. So what I actually want to do is I want to print an error message if it's a left. So the way you do it is by defining a fold condition on the left and the right. So a fold function actually. So you have a fold which says f and g, takes two functions, and it returns the right, executes the right function as you would expect. It's the data, and it ignores the left function. The left ignores the right function and runs the left function. So the left runs the left function, the right runs the right function. So what you can do is you can come here and eventually you can fold, and you can say print an error message, or in my case the print error was this function which I defined here, which simply prints the message. So if the value in the chain was a left, when you fold the data eventually you want to print an error message, and if the value in the chain was a right, eventually you want to load. This is what I'm saying. So let's look at our data. The age is 12, the min age is 18. I'm going to run this. It's going to say, oh, you need to be above 18, right? Because we had a left, so the show publisher message never ran. And now if I make it 22, I am going to run this again, and notice how the show publisher function executed, and it printed the message, and then it tried to load. So notice how by simply encapsulating something in a right or in a left, I was able to write a simple a program in a very linear fashion, and only have to decide what to do at the end of the code. If it's an error, or if it's a failure condition, I have a left to execute. If it's a success condition, it's a right, and nothing in between breaks. This is the beauty of how an either encapsulates uh, a conditional. Now you might think that, hey, I had to go ahead and change my access game function and return a right, return a left, but there's a way we can work around that. So I'm going to talk about that in the next video. But for now, this is the simplest way that you can use an either to encapsulate a condition in functional programming. See you in the next video, and thanks for watching.